I'm drilling, and the experiment I did was the condiment diver, where we get a ketchup packet, which represents a diver, and we put it into a water bottle, which then represents the diver. And once we put this in, it'll either sink or it will float, which shows the buoyancy of it and how, like, when you put it in, if it starts to go down because of the air pressure, which displaces less water, it will sink. But once you leave it and you release the pressure and the buoyancy increases, allowing it to float. So what I first did was I poured water into here, and I put all the packets into the water, into this cup, seeing which one will float. And the one that floated was this. So now I'm about to put this one into here. Once I grab my water, I have to put my packet in here. And you see it starts to sink, but then it goes down. So I'm gonna put a little more water, see if that changes anything. Then I'm gonna put the cap on. And once I put the cap on, I start to squeeze. And it starts to go down, which is decreasing the buoyancy because the packet is displacing less water, which is allowing for the packet to sink at the bottom. And because of the tight pressure that's there, tight particles. And then once I leave the water bottle, once I release the pressure that's there, the buoyancy increases, which allows for the packet to come up and to float and to be like alive, basically. So the diver's alive instead of just sinking when I squeeze it more and apply hard pressure every time. So when I stop it. And so basically, the diver will either sink or will either float based on the amount of pressure that you apply to the bottle. Applying more pressure will allow for the packet to displace more water, which will decrease its buoyancy because it's sinking. Once you release the pressure on it, it will display water, which will allow for the packet to increase back up and increasing the buoyancy, allowing it to float. Thanks for the experiment. That's the experiment. Thanks for watching.